right, hopefully my voice is not too jarring for a Explore Wednesday afternoon. I'm here to provide you with a lot of knowledge and bad jokes. That's what I'm here for. It's what I do on a daily basis. Plus some NSX education. That's the fun bits. So, my name is Jason Cowley, and with me I have Quentin Coelho. Oh gosh. Quentin.
Good afternoon, guys. My name is Quentin. I'm an NSX Security COE. Oh, on the stage. Sorry, guys. So my name is Quentin. I'm a NSX Security COE. I cover Middle East and Africa. And my core focus in VMware is on the NSX Security ATP product. And myself and Jason, the team, going to run through this lab with you guys today.
Perfect. I'm a NSX TAM, which essentially means that I help customers utilize and adopt NSX in all the fashions that it has. So network components, security components, just about anything and everything. This is not our day job. We do this because we like doing this. We like building these labs. We like educating you all. We like being a part of Explore. And we like just imparting more knowledge. We get a lot of energy out of this. We did not do this alone. This is a huge group of people who helped build these labs. One of them is Lynn Dark, who's over here on the side. And she helped build a bunch of the content for Module 6 and 7, 1, a whole bunch of them. So we're very grateful for everybody who can help make this a collaborative experience. And we're all here happy to teach you. Today, we're going to be talking about NSX security. So who here has some familiarity with NSX security? Just a little bit or a bunch of bit? Little bits. Cool. All right. Is there anyone who's got a lot of experience with NSX security? Cool. That's totally fine. The good news about this lab is that we have everything soup to nuts for NSX security. We have everything from the most basic components of the distributed firewall to the most advanced components with the advanced threat prevention packages. So no matter what you want to learn about NSX, whatever security pieces that you might be curious to add to your environment, we got information in this lab. So we're not going to cover everything in here. In this setup, with these people live here today, we're going to cover just some components of the NSX security. But feel free to pull up a 2426 and take this lab again, learn more, find all the different components and pieces and what's applicable to you and your environment, and learn what you need to learn. Cool. So I'm going to give you a real quick sort of a rundown on constructing the lab, but I actually want to do one thing first. So part of what we're going to do today is the advanced threat prevention, and advanced threat prevention actually needs some time to spin up and get running. So we're going to start this whole thing by enabling some features in your lab, and then we'll come back and do a little bit more of the fun marketing stuff, and then we'll go back to the live lab stuff. So in your lab, you should be here at the course catalog. You've already started this lab, we should be okay. But if you haven't, go ahead and hit enroll. I'm going to enroll again because I've done this lab once before. By once, I mean several hundred times. Perfect. So this is going to take just a couple of seconds to spin up. And then we're going to get really jumping into a few of the, turn on some features, and we'll talk a little more, and then we'll do some more configuration. I'll talk about some of the basic components of NSX and distributed firewall, and then Quentin will talk about some of the advanced threat prevention stuff. It's good fun. Perfect. So you should end up at a lab screen like this, something that is nice and clean, fresh desktop, looks good. You may or may not have this ready state here in the bottom. That's no problem. If you do not, we're going to double check that everything looks clean and ready for you regardless. So go ahead and double click into Firefox. You should start this up. And log into NSX. We have those credentials pre-populated for you. You shouldn't have to do much of anything. Perfect. So if you've done any NSX before, then you're familiar with this screen. What might be new is all the advanced content. So let's go into System. And then we'll click NSX Application Platform. So NSX Application Platform you may have heard of as NAPP. And this is a prerequisite for a bunch of the advanced security features inside of NSX. A bunch of the advanced security features require some extra workhorse power because they're very powerful analytical tools that are monitoring traffic constantly or providing security recommendations, things like that. Those are things that are so CPU intensive that we didn't want to put onto the hypervisor to make it happen. And so we built this Kubernetes cluster external, essentially, that is just workhorse machines to provide these abilities. So we've deployed NAPP for you. You don't have to worry about that part. All we're going to do is turn on some features. So once you're here on this NSX application platform, you should see a stable platform. So that's sort of the critical component here, is that this platform is stable. If your platform is not stable, you let us know now, because we need to correct that before we can really do much of anything for the advanced threat prevention for you moving forward. So I'm not seeing any hands. No one's crying. We got one babber? Okay. Quentin's on it on top of he's good at this. Perfect. So for everyone who has got a stable NSX application platform, go ahead and scroll to the bottom here with that scroll bar. And the first thing we're going to do is activate NSX Network Detection and Response. Okay, so you can just hover over that and click that Activate button. First thing we're going to do is select a cloud. We're in the United States, so we're going to select the United States for this. And all the cloud content here is connecting to United States. So select our cloud that we'll connect to, and then we can scroll down just a smidge and hit Run Pre-checks. All this is doing is checking for licensing, checking some certificate stuff. We've already pre-built this for you, so there's no work involved on your part. Once NAPP is running, we just do this double check of everything, of the scenario and the situation, before we activate the feature itself. So we'll let that run for a minute, and hopefully everything will be good. And if anyone's having problems, we got several people running around to help out. I don't see anybody panicking. This is great.
Cool.
All right, once your pre-checks have run, you'll see this little completed here, and you can run through and see what it was checking. But really the important bit here now is just to hit that Activate button. Cool. So that's going to take 8 to 10 minutes to activate, so we're going to jump back to the slides, and I will chat at you for a little while, and we'll just let that run for a bit. Awesome. So I want to talk about constructing the lab, right? Because hands-on labs are kind of an interesting thing. I just told you that we already pre-built NAPP for you, and if you've looked at NAPP, it's a whole Kubernetes buildup, right? That seems kind of strange that we built a Kubernetes environment for you just for a lab. Well, the entire construction of the lab includes a whole bunch of different things, and it starts a long time ago. You can see here that we essentially started the concept for this setup and this lab in January and February. We were talking to the network and security business unit, engineering, product management, saying, what are we going to show off at Explore this year? At that point, we get an idea of what's important, what's interesting, what's coming, what's new, what can we build out in time to be presenting at Explore, and then we start building the pod. So Quentin, Kevin, a few of the other people on our team, they start building out a pod. And this is essentially like a VCD setup where we build out an entire application. So the pod itself actually has a vCenter, it has an NSX manager, has a Kubernetes setup for NSX application platform. It's got about 15 virtual machines that are running in there on 4 ESXi. So we have a very dense sort of setup, and I know 15 VMs on 4 ESXi doesn't sound dense, but you got to remember these ESXi are actually virtual machines. They are VMs that are running as nested components on actual hardware. So once we've actually built out that pod, and we'll get into a little bit of the details of those in a little bit, then we start writing the manual. So me, Lynn, we spent a lot of time on this. It's basically a click by click. If you've never touched NSX before, that doesn't matter. What it means is that you can log into NSX and we will teach you every single step of the way what you would do to configure this, to understand it a bit better. We have screenshots so that you can make sure that you're following along exactly step by step. Everything you need to click, everything you need to type. Right? We want to make sure that you understand something, that you learn something from this lab. And that takes a lot of work to make sure that it's very clear and concise and everything fits. This is the actual full topology of the lab. This is the full deployment of the lab. And you can see here we have one data center, we have one vCenter, and one NSX manager. You know that one NSX manager is not a supported configuration, and we're doing a lot of not supported configurations in this setup. We are running on a skeleton to make sure this whole thing runs and functions appropriately, but at the same time, we can kind of get away with it because it's very temporary. This lab will exist for about 2 hours before you end your lab. It gets destroyed. And the next time you want to build it, it'll be a completely new setup of labs. A whole bunch of scripts run, build out a new setup. You get a fresh deployment. You can test whatever you want. It's one of my favorite things about hands-on labs is that this is a great place for you to test weird APIs, weird configurations, things like that. If you've never played with NSX before and you don't want to build a home lab, spin up a hands-on lab, right? Build something, try it out. Postman's built into this. You can try an API, you can see how this works, you can see if the error you're seeing in your setup is also replicated when you make that change in a hands-on lab. You can learn a lot from these. So definitely recommend these as a troubleshooting tool effectively whenever you're working on your day-to-day. We reuse a whole bunch of content in here, right? I said there were about 15 VMs. You can see that the 3-tier application there is used in almost every one of the modules. So that is a simple 4 virtual machine, 3-tier application, web to app to DB, right? Normal communication for a 3-tier application, and we reuse that sort of setup module after module after module, right? So we make really good use of the resources we have. So even though we cram a whole bunch in here, we want to make sure that it's efficiently used space. So it doesn't take 3 years for the pod to spin up for you so that you can make use of it. It takes 15 minutes instead. So if you're curious, this is some of the stats on the content. When you build out a lab and you get this fresh environment, this is all the stuff you're using essentially. You got over 2 terabytes of storage that we utilize for every single one of these labs that gets built out. We have over 80 firewall rules that are keeping you safe from the outside world and also keeping you from getting to the outside world. Only very specific connections are allowed out and in. And then we have, some crazy CPU utilization going on, a little maybe hotter than you'd feel comfy running on a day-to-day basis because all of this is virtualized, as I said. And so we're running pretty hot as far as our CPU utilization on our virtual ESXi go. I like this. I think it's just sort of a fun slide just to understand the hands-on labs a little bit better. Perfect. So I mentioned earlier, sorry, do you want a picture of that? You got, okay, cool. Cool, so I mentioned earlier that we have everything soup to nuts on NSX security in this lab, right? We have everything, most everything you could want to know about NSX security built in here. So everything from the very basic, distributed firewall, gateway firewall, identity firewalling. I think those are 3 critical things that most security admins that are new to NSX should probably get their hands on and understand how it works, why its function, what its function is, where it's beneficial, things like that. So distributed firewall, I'm going to cover with some depth and detail here today with you all. And then things like identity firewall. I think this is super critical. This is essentially if you have a golden image VDI machine and you have users that would log into that VDI machine with different Active Directory groups. Well, based on the Active Directory group, they get different permissions inside the machine. So IT admins who log into this VDI machine could do SSH traffic, whereas a regular application admin that isn't IT admin could log in and get HTTP access instead, and not allowed for the other opposite way of that. So I think that's a very useful module for anyone who's the administrator of all things, as I used to be. It basically used to be if it had an on button, I was the IT support for it, and I imagine many of you can relate to that. So if you're doing VDI and you want to secure it a little bit better, definitely check out Module 2. Gateway firewall, a lot like the distributed firewall, but sort of the perimeter of NSX itself. A lot of value in that as well. We're also going to cover Module 7. So this is the Advanced Threat Prevention. Advanced Threat Prevention is all the newest, greatest, coolest, super cool security pieces. This is malware detection, IDS and IPS built into software, network traffic analysis, understanding what's normal traffic and what's not normal traffic, what's abnormal, right? And then giving you alarms or preventing that traffic from occurring. So we have a whole bunch of stuff in here. NSX Intelligence, really useful tool for analytics of your environment. Looks at your flows, looks at your groups, recommends distributed firewall rules for you. Very useful. So we're not going to cover everything on that. We're just going to cover a bit of it. Basically, our plan is to hit 1 and 7. If we have time, we'll go through some of the NSX application platform, but it looks like a bunch of our crowd here today is newer to NSX. So we won't go too deep into NAPP because it's just sort of a prerequisite to getting Module 6 and Module 6 and 7 NSX Intelligence and ATP content built out. So we'll stay on 1 and 7 for the most part. All right, this is my fun marketing spiel, and I actually think that this is fun. As much as I'm not a marketing person, I'm definitely a technical kind of person. That's how my brain rolls. This is a fun little bit of a presentation on the security side of things. One sec. So, security for the data center effectively has changed in the last couple of years, really, right? It used to be that we basically had a perimeter and everything was fine. Perimeter firewall was sufficient for most of what we needed. And we could have physical boxes because we had physical servers for IDS IPS, metrics and analysis of the traffic inside the data center. But everything's been virtualized, right? At this point, mostly 80% virtualized for a lot of customers that we see at VMware. So if so much of your content is virtualized and a whole bunch of it has become new endpoints, we no longer have a physical server as an endpoint, we have 30 servers living on a server that are all endpoints. So at this point, we need to secure more of the components. It's no longer a perimeter game, right? Because if somebody were to break in past the perimeter firewall, everything inside is free game, right? Everything inside, it's easier to get to. So as a real world comparison, the old world of security in data centers was perimeter firewall. Somebody breaks in, and in a real world example, this means they break into your house and they steal your tax returns. And that's frustrating and it's annoying, it's a violation, but you know exactly what they took. And then it's gone. And that's not how it works anymore. Instead, attackers are now breaking into your house and living there for 6 months. And they occasionally put a lock on a cabinet, and sometimes they steal your snacks, and sometimes they kick your dog out and you don't know what's going on until suddenly you just can't get into the house anymore at all, right? It's an absurd example, but it's really how things have been working. SolarWinds, Log4j, these were not things that was a smash and grab job, right? They were there and they lived there for months and months on end before they started exfiltrating data and dropping ransomware everywhere. So lateral security is the new battleground for anything security related inside of a data center. Everything virtualized. If you're actually going to adopt a zero trust policy, it means you have to assume that you're already compromised and that someone's already inside your environment. And if that's the case, then you need to know how to evict them before they can do any damage, right? So it's no longer about keeping yourself secure at a perimeter. They might already be in. So what do you do about that? Once they're inside, we're at a point where this lateral movement becomes super easy. We don't have things locked down internally. Everything needs NTP. Everything needs Active Directory. Well, those are just bridges for bad actors to get through your environment and say, great, I've found my way to a database. I found the useful information I want. I want to drop some, crypto on there so that it's now encrypted and you can no longer get on, and exfiltrate all the data I want, and then send you a bill for, a whole bunch of Bitcoin. So with that, this is where VMware started creating all these solutions to help with that problem, right? So we've had these solutions for a long time. Physical firewalls, physical IDS and IPS, physical analytics tools, right? But they are no longer sufficient, as I mentioned before. With so much of our content virtualized, it means that these have blind spots. That's the easiest way to look at this, right? If this was server-to-server communication that have to go through a top-of-rack switch to communicate, then that's fine. But if you have two VMs that are using networking, a software-defined network, they want to communicate on different networks, that never touches a physical wire. We don't get to see that traffic. We don't get to inspect it for IDS, for firewall, for anything. That means we have blind spots. And that means that lateral movement that we're concerned about is very easy. So VMware did what VMware do. We virtualized it, right? We push all these things that used to be physical boxes, and we turned it into software and put it into the hypervisor. So the IDS IPS, the distributed firewall, these are all things that are built into the kernel. As soon as you install NSX, you have the capability to be doing things like IDS and IPS and distributed firewalling at the kernel inside the ESXi, which means that we're applying a firewall around every VNIC of every virtual machine inside of a data center. So we don't have a perimeter firewall. Well, you can have your perimeter firewall, I don't mind. Keep your perimeter firewall, that's great, it's gonna do some heavy lifting. But inside the data center, where everything's virtualized, let's put a little miniature virtual firewall around every single one of them. And it's not an agent that gets installed onto every ESXi or every virtual machine. We're already there. If you're using NSX for your networking, then we're already looking at the network components of it. NSX owns that network already. So that means that we can actually insert a firewall into that line between the VM and the VNIC of the virtual machine, and then the network it's connected to. We're right there already. We may as well just do a little bit of extra inspection and keep everything more secure. So that's the piece I'm gonna talk about, is the distributed firewall, right? We're gonna do this nice, cool live lab on basically separation of content and what should be and shouldn't be allowed traffic inside of an environment with a distributed firewall. And then I'll hand it over to Quentin. He's gonna talk more about the ATP stuff, which is all the malware detection, IDS and IPS and things like that. So we're gonna swap real fast. Back to the lab. So first off, your network detection and response should be green and good and happy to go at this point, right? So I haven't done anything in the meantime. You've been watching me. Our status is up. Everything's looking good. If that looks good for you, excellent. Go ahead and then also activate malware prevention, right? Quentin's going to utilize both those features, so we'll activate both of those now. It'll utilize the same cloud, so you don't have to select a new one. We already selected the US cloud before, so this one has auto-selected that. So you can scroll right down and run the pre-checks for the malware prevention real fast.
If you are still waiting for the NDR piece to activate, no problem, just wait a little bit and then activate the malware once it's there. I see some of them are slightly behind.
I spoke too quickly. I'm just too fast sometimes with all my marketing slides.
No problem, man.
Perfect. So if you've started your malware prevention pre-checks and they're all good to go, you can click activate. We do want NDR to be activated before we try and activate malware prevention. So as Quentin said, if you haven't quite finished with the NDR component yet, let it finish out before you start trying to activate a second feature. But once you've gotten this one up and good and you started the activation for malware prevention, then we can just let this run. So I just want to make sure we got that running before we jumped into anything distributed firewall related, so that it's good to go for you and Quentin when we get to that part of the presentation. Perfect. So we're going to do some security stuff, so go ahead and click the security up here at the top. This is going to be module 1, and feel free to ignore me and run module 1 if you want. I won't take it personally, I promise. I'm not going to follow the module exactly, so feel free to follow along with what I'm doing. I'm going to skip a bunch of steps, but I'm going to give you a whole bunch of knowledge as we go as well. So if you prefer to do the manual click by click, feel free to do that. But you can do that at any time. So you signed up for the Exploited Workshop. I'm here to lead expertly. Perfect. So click your security, and then we're going to go to the distributed firewall. So this is the distributed firewall. This is the baseline security feature of NSX, and it is an incredibly useful tool for a lot of reasons. This looks and behaves a lot like any other firewall you've probably seen in your career. This is a top-down, left-right firewall. What does that mean? That means that if you expand these rules, we have 3 sets of policies here that each have 3 rules inside of them. So we have a bunch of rules running here, but top-down, left-right essentially means that when a flow goes through the distributed firewall, it's going to check the rule 1, rule 2, rule 3, rule 4, et cetera, et cetera. And once it hits a rule that is allow or deny specific to that flow of traffic, it no longer has to pass through the remainder of those rules. So if it hits flow 3, or if flow hits rule 1 and says we're good to go, it doesn't bother checking the remaining 8 rules. So to be efficient in that, all that really means is that we want the commonly used rules, the flows that will communicate often, to be near the top, just so that we have efficient use of our firewall. That's the best way to do it. Go ahead and minimize those though, because the one that I really want to focus on is default. When you build out NSX for the first time, this is the only policy that will be there, and you can't get rid of it. We won't let you. You can't delete it. There's no way to do it. And you'll notice this last rule here is the default layer 3 rule. Now this is, as you can see, the only rule with the toggle unavailable to change. This rule is on no matter what you want to do. You cannot disable it. What you can do is decide whether you're going to allow or disallow traffic as your default rule. So most scenarios and most customers that I see, this is set to allow, because it's easier to say, we see a bad flow, block that flow, right? And you set that up for things that you know you don't want to allow inside your environment. The true zero trust policy that you want to try and achieve would be have this as a drop. This default rule is don't allow traffic. If I haven't explicitly allowed it above here, it's not allowed at all, right? That's always kind of the goal, and it's not easy to do. It takes a lot of administration and a lot of overhead to make a rule set that actually fits your entire policy and allows only what you want to allow. There are tools that will help with that we'll talk about later called NSX Intelligence. As a great means for you to understand what should be allowed inside your environment so that you can set your default rule to be a drop. So let's try this out. Let's change our default rule. Well, actually, before we do that, because I want to show you that it works first, let's open up a tab. And we will go to this 3-tier app bookmark section and just run Web01 or Web02. This is a really simple 3-tier application that is essentially a we as a client access a web application. The web application communicates to an app component, and the app component pulls information from a database and displays it back to us, right? Very simple 3-tier application, standard for a lot of setups, right? So once we've opened the 3-tier application, it should work. If it doesn't, let us know. But now let's go break it, all right? Let's be really secure IT admins, and we will change this from allow to reject. So go ahead and change your default rule specifically to a reject and hit publish. Now this means that if we haven't explicitly allowed a flow ahead of this reject rule, it's not allowed at all. So let's go back to our customer database and reload that page. Bam, we know that's not working. And the reason is we haven't built any rules that are actually allowing these flows of traffic to communicate, right? So let's be good IT admins and let's go build some rules that will allow this communication. And since we're lazy, we're gonna do this already for you. So we built this 3-tier app. So if you expand this policy, this is the 3-tier application distributed firewall rule policy for you. So if you read through these rules, we're essentially allowing any source to communicate to the web to communicate to the app, and the app to communicate to the DB. And we set specific services that we are allowing for that type of traffic. So for example, any to web application means that any HTTP or HTTPS access should be allowed from any source to the web destinations. So we can enable that and publish our changes. So just that first rule of the 3-tier app, go ahead and change that and allow that communication. And now if we go back to our 3-tier application and refresh this page, this is different, right? And so we could get to here, but the web couldn't actually communicate to the application itself. So let's go enable the second rule and see what happens. We'll enable this web to application component and hit publish. Come back to our 502 back gateway and refresh one more time. Then we get the database, we get no content. So everything's been allowed at this point. Client can access the web can access the application, but the application can't pull any data to display. So let's go enable that last rule real quick. We'll enable that app to DB component, publish our changes, and refresh our database. And now we're back. We got the full setup now, right? So now we're being really good security admins, right? We have set specific rules that allow the traffic that we want to allow and disallowed everything else. So if you tried to SSH into this, this web application, it wouldn't work. That's not an allowed port, right? We specified that we are going to do HTTP and HTTPS only. So anything that isn't allowed specifically, not allowed at all, it will be denied. Questions on the baseline here on the distributed firewall, anyone? That's a great question. His question is, when is it appropriate to use reject instead of drop? So Eagle Eyes found that we chose, of the 3 options, reject instead of drop here, right? This is a great question, and we get this a lot. Reject essentially means that when a traffic flow occurs, the default rule here will send a response that says, you're not allowed to talk to that, go away. And that's really good for our presentation here today because it means we got a really quick timeout on the customer database, right? We have a quick turnaround that says, you're not allowed to do this. If we had instead chose drop instead of reject, then we get a timeout, which basically means we could spin at that 3-tier app for about 20 seconds before we're like, hey, we got no response, we don't know, we can't get there, I'm not sure. We still didn't get there, right? Security-wise, we're doing the right thing, right? We've denied that traffic. So it really depends on the specific scenario that you want to do. A drop is very secure in the fact that a bad actor may not know that they hit an endpoint at all, right? So that's great if you want to keep something secure through some obscurity. Reject is good if you're having a user that's not hitting something that should be allowed to hit. You're trying to access a web page that we don't allow. So you can't get there. You know, give them the immediate reject so that they aren't waiting 20 seconds just to hit that same deny. So it really depends on the scenario. For this, we choose a reject. I'd say most of the time you want to do a drop. Good question. Thank you. Excellent. So one other thing that I want to call out here is the applied to field. So if you're used to physical firewalls, this is probably some field that you've never seen before. This is a whole entire column. You've seen source, destination, services, even layer 7 for context profiles. That's all stuff you've probably seen before, but this applied to field, that's something different. So this is something that makes the distributed firewall unique compared to any physical firewall you can see. There's no physical component that can do it like this. The applied to field means only apply this rule to the things that are in the applied to field. So in this example, right, this is the 3-tier application. We have built these rules, which is for 4 total virtual machines. These rules don't need to be applied to any other VM in the environment. These rules are specific, right, to this setup of application, these 2 web VMs, this 1 application, this 1 database. If we have some other Oracle database, it doesn't need these rules because nothing will ever try to communicate to that Oracle database in this regard. So why bother applying rules to it? That makes no sense. Let's be very, very efficient, right? So if you hover over the applied to field here, you can see on this first rule it says 3-tier web servers, because really that's the only servers that need this rule, is the web servers that might receive this traffic to these web destinations, right? And then here, our second rule is our web to app. So our source says 3-tier web servers, and our destination says 3-tier app servers. So in our applied to field, we have the web and app servers. They're the only machines that need these rules. There's no reason to apply these rules to everywhere else. If you build a rule by default, it is applied to the distributed firewall, which means it's applied to every VM inside the NSX environment. That's great because you're applying good firewalling, but it's inefficient because you're applying rules that don't need to be where they're living, right? So best practice, in my opinion, is your applied to field should essentially look like your source and destination fields combined, right? If it's source and destination, those are where your applied to field should be, and it's the best way to keep things very, very efficient. If you're curious about this, you can actually go into the ESX CLI, pull up a VNIC of a virtual machine and say, do a vcip IOCTL and find all the rules applied to a virtual machine on an ESXi. And you'll note that those are only very, very specific rules, right? So we can see very quickly what's an appropriate rule built for the virtual machines and what may be extraneous, right? So there's a lot of good tools that we have to help you understand when applied to is a good choice. And in my opinion, and this is my professional opinion because I am paid to know this, it's best to use applied to just about always. One moment, I'm gonna have to come to you because I can't hear you, sir.
It's okay, Jason, I'll pick it up.
The shared infrastructure, would those also going to be applied to?
So the question is about the infrastructure rules?
Infrastructure rules? So we're talking about the differences in Ethernet, emergency, infrastructure, and environment, right? Is that your question?
In the applied to, would you include your DNS servers, NTP, etc.?
That's a good, okay, so he's asking if in the applied to you include your DNS, NTP, that sort of thing. The answer is it virtualized? If it's not inside NSX, we can't put it in the applied to field. We can't apply security rules to things that NSX doesn't control via its own networking. So if you have physical NTP servers, physical AD, something outside of NSX is a managerial component that's very common, then no, we cannot. But you do sort of bring up an interesting point, is that what if we do have these shared services that are needed by a whole bunch of components, right? Well, there are different ways the distributed firewall can be utilized. Now, before I said top-down, left-right, and the top-down makes a lot of sense after we've talked a little bit. The left-right is a little less intuitive until you look at these pieces here. So at the top of the distributed firewall, we have Ethernet, emergency, infrastructure, environment, and application. And you'll see that we're working in application. Well, we can actually be building rules that are specific to something far, far broader than an individual application. So here, if you look at Ethernet, this actually includes our default rule. This is just that last default rule that we set to be an allow. If we go to emergency, this is where I would say you set up rules for troubleshooting. Something's not working in the environment. You build an emergency rule that says allow traffic to this application because it's not working and we don't know why. If suddenly everything starts working, you know the distributed firewall broke it, and then you can fix it. Right? You can find somewhere in the application level rules that it was not working. If it doesn't if nothing is resolved by adding an allow rule here, well then you know that the distributed firewall wasn't at fault. Infrastructure, this is where I'd put those DNS rules. You put NTP, DNS, things like that. So if everything needs to be communicating NTP and DNS, well, let's get that in ahead of the rest of the application level rules so that we're allowing, we know this is our good NTP server. Anything can talk to NTP, that's fine. Give it some specific ports and protocols, specific destination if it's in the virtual environment, or specific sources if you know these machines need NTP and these don't. That's a good way to do it. Environment, this is where I would do something very broad, like a prod, non-prod separation. Okay, so this is, that network can't talk to that network, that sort of thing. And then application is where we're getting into port, protocol, 3-tier app kind of level details, right? This is where you get really nitty-gritty about this is allowed and everything else isn't. So the easiest way to do this is definitely start at the left and move your way to the right. Build the content for infrastructure and environment, and then get down into the application level if you need to. Very good question. Real quick, I don't want to eat too much time because I want Quentin to be able to chat for a lot longer than me, is the dynamic grouping. So you'll notice here, if you click on any of these groups that are in a source or destination or applied to, go ahead and click on any one of those. I've clicked on the web servers one, and you can see here that it includes Web 01 and Web 02. This is beneficial because we've done this dynamically, all right? So go ahead and click on the group definition of this, and you can see that we've done this by tags. So what we did is we tagged these two virtual machines with an app tag, a web tag and a 3-tier tag. And all that means is that there was an NSX tag built, and then we say any 3-tier application gets this tag, this 3-tier tag, and all the web machines get this web tag. And that means if we needed to scale this application out, that's no problem. We clone a couple of virtual machines, we build 4 more, and now we have 6 web VMs. Well, they got those tags, so they are now automatically included in these security rules, right? We didn't have to go change the firewall at all. We just said, hey, if it has these tags, it gets this firewall rule policy. So we scale up that application. We now have 6 web VMs, and we didn't have to change the distributed firewall rules at all because they're dynamically including those new 4 VMs. Now the weekend's over, we can scale that back to 3. We delete 3 of those virtual machines. Well, those 3 VMs don't exist anymore. We don't have to go clear 3 ports from the firewall. We don't have to go clean anything up. The distributed firewall is doing this dynamically. It says, I don't see those 3 VMs. We have no need to apply rules to them. They don't exist. Doesn't matter. We didn't do it IP by IP. We did it through tags. You can actually click edit here and see a bunch of the different ways we can do dynamic inclusion. It doesn't have to be tag-based. I know tags aren't always the easiest dynamic inclusion component, so we have other means to do this. You can do something based on operating system, so if you have a whole bunch of Oracle VMs, something like that, or computer name. I have a customer that does everything that, if it's pre-prod, it's pre-prod is in the name of the virtual machine, and then once it graduates into being a production, that pre-prod naming convention gets deleted, right? So everything pre-prod is automatically found with computer name starts with pre-prod, and you could just put that in, and suddenly any VM inside the environment that says pre-prod, it gets pre-prod rules, which means, hey, it's not allowed to talk to production. If it's missing pre-prod, it's not a pre-prod machine, you can't speak to that machine. So that's a dynamic inclusion thing, because then you could go change that virtual machine, change the name of the machine itself, delete that pre-prod component of the naming, suddenly it no longer has pre-prod tags, no longer has pre-prod dynamic inclusion. You get a different set of firewall rules because it's no longer a pre-prod VM. So dynamic inclusion is very, very powerful. And it's another thing that physical servers really can't do in the same regard. We have an advantage being NSX, being a part of VMware and so close to vCenter that we're very included in all of the knowledge that the ESXi and the vCenter already have. So combining more and more of your VMware components together, you get more and more advantages of this. You can also do a lot of tagging based on things that VRA builds for you. If you're an automation shop that builds content out with VRA, you can have something always spit out the exact same way, which means NSX can be prepared to handle it in a security fashion in the same way as well. So go ahead and cancel on that. We don't need to make any changes to that tag, but I think it's important to include in knowledge. Real fast, before I hand it over to Quentin, I'm going to touch on this component here. So if you click this little gearbox, there's some settings for logging. There's also a direction, you can do directional flow for these. You can say, this is specifically a flow into this server or out of that server. pretty much always leave this as in-out. Since we're applying at the VNIC of the virtual machine, why not do the security for both directions at the VNIC? It costs us nothing as far as compute power. It costs the virtual machine nothing to do this. Beneficial almost always to do in-out. The only reason you might change this, I would say, is very, very, very specific application flows or troubleshooting, perhaps. The other component of troubleshooting that I want to chat about here is logging. We've enabled logging for this, which essentially means anytime this flow is hit, whether it's, whether we've changed this as an allow or a disallow rule, anytime this flow is hit, we send a log off to our logging server. So what's beneficial about that is you can also throw in a log label, right? So here we have the 3-tier client access, very specific. It's specific to this rule, right? But it means that anytime this flow is hit, we send a syslog server message that says, this flow is hit, here's the log label. So if you go into your syslog, you go into ARIA operations for logging, you go into Splunk, and you look for this tag, you'll find it. It'll be there inside the log message, which means that you have really good information about when this was hit, which means that you can use this for a troubleshooting tactic, right? You change your log label to troubleshoot, and then you say, well, listen, we've run this application, and it's working fine. We check the logs, and we see the troubleshoot tag come up every time you hit it. There's nothing wrong with the firewall. It's passing the information along. Your communications are working fine. Something is wrong at the application level itself. So awesome troubleshooting tactic. I've used that many, many times. Perfect. So before I hand this off to Quinn, I want to make sure everyone has this changed from a reject to an allow. All right, so go ahead to that default rule and allow that traffic and publish those changes. We can leave the 3-tier app intact, enabled, disabled, whatever state you've left it, it's no problem. But Quentin's going to do bad stuff, and if our distributed firewall is blocking that traffic, then you don't get to see much information, and that's a lot less fun. So make sure your default rule is set to allow, make sure you've published, and you're good to go. All right, I'm going to throw this back up for Quentin. Up here. If you have problems, questions, throw your hand up. Either myself, Quentin, or Lynn will help you out, or Priti. So we got a whole crew of people here to help you out, answer questions if you have them.
Before I get started, I just want to check if everybody can go back to system. Let me sit down. Go to system, NSX application platform. And I just want to confirm that everybody has NDR, or network detection and response, is green and activated. If you scroll down a little bit, you should see the same status for malware. Anybody that is not at this point, just raise your hand and either Jason or Lynn will quickly come help you out. But I think by now everybody should be fairly activated. Cool. So Jason took us through the distributed firewall. He mentioned layer 3 to layer 7 capability. But if we look at the nature of attacks today, a lot of this is either through malware, ransomware, or taking well-known exploits that are potentially not patched in your system. So the web application that you are using, imagine we've opened the firewall, we allow the HTTP or the HTTPS traffic, which is what we want users to connect on. But maybe that web server is running a version of a web browser that has a well-known exploit, and somebody from the internet types in a string in the browser, puts a certain characters attached to that, and gets CLI access to your machine. This happens all the time. Why? Because users are not actually updating and patching their systems. So what are the additional features that we're going to cover now that NSX brings you? The first one in the middle, this is an IDS IPS capability. We bring this at the distributed level, so the same way we do with the firewall, you can apply these IDS IPS policies at the VNIC of each machine. But we also have that on the NSX gateway, which is the north-south routing point. So if I take the example of the web server, imagine that web server is running Apache, maybe it was the log4j vulnerability that was exposed or some other vulnerability. You can now go and use the IDS IPS signatures that we have, and we'll show you just now how we create profiles and stuff like that. and actually apply dynamically an IDS IPS capability to that web front that actually protects the machine using this IDS IPS engine and gives the system owner some time to actually go and test the patch on their environment or in their staging environment. So we refer to this as a virtual patch use case. And then there's a lot of different use cases for IDS IPS. On top of that, we spoke about earlier, he showed the graphic of the guy sitting inside your house, dwelling around. This happens inside the network as well. People are gaining access, same way maybe through their web server, they exploit. From there, they do lateral movements. We talked about the new battleground. The firewall does its job. You want to lock down and prevent that lateral movement, but it still happens. And this is where the NDR bit actually starts correlating events that are taking place, looking at flow analysis, and correlating potentially a IDS IPS event to something else. And on top of that, we say malware prevention. So we also provide a sandbox capability in the NSX Advanced Threat Prevention package. The sandbox can be two-front, either a distributed malware solution, meaning that on each of your ESXi servers, we will install what is called a service VM, and at that point, we actually will intercept the file that is downloaded by the machine, and we'll see in our lab, when a file is downloaded and it wants to write to the disk, we intercept that file using the guest introspection protocol, and we take that file and we scan it on our sandbox. We also have this capability on the north-south gateway. In this lab specifically, it's going to be on the north-south gateway. So what we're going to do now, I'll just give you a quick rundown to understand what we're going to do as we go back into the lab. We're going to simulate what a typical attack would look like. Again, it's just a simulation. What we are doing is using some TCP dumps, some simulated malware, and playing this out in this environment so that we can turn some of the features on. So we call it like turn the lights on. And then you can have a good understanding of the capabilities, look at how we trigger the IDS IPS, look at how we trigger the malware detection, and then how the actual NDR engine is doing the correlation of these events. So we, first point, we simulate this VDI user. The VDI user potentially received an email either internally or externally, maybe something about claim your prize, or your package has arrived, or pay $2 to get your package delivered. Maybe he's excited waiting for Amazon package and he clicks on the link, pays, and with that he potentially downloads a file. And that causes this command and control event, which then threat actors be able to get remote access to that machine and then start controlling that machine. From there we see the typical lateral movements. So land on the web server doesn't have much use to me. I actually want to be able to move around and either look for a database or look for some form of potentially encrypting the machine. So it really depends what we want to do. So because this VDI has access to the web front had that vulnerability, I can now actually take control of that web front and eventually move my way through to the database. And as you can see, do some data exfiltration. So in this demo now, we're going to use these 3 VMs. We're going to use a little bit of the work that you learned from Jason, creating a group, putting these 3 VMs into the group. And again, we're going to use that apply to capabilities that we mentioned. And when we use the apply to with the IDS IPS, we are basically saying, I want to enable this IDS IPS policy on those 3 machines. So I'm going to keep it simple. It's just source and destination any. The group that we're going to apply it to is going to be these 3 VMs that the group we create. And then I will just quickly create a default profile as well. And I'll talk a little bit about the profile in the actual solution. So if we match some of the capabilities, how do we detect some of these threats in the environment? So it'd either be our sandbox. So the sandbox capability can detect that file when it was downloaded. Depending if it's distributed malware or gateway. On the distributed malware, we can actually do detect and prevent today. On the gateway, which we are using in this lab, it's only detecting. And as we move through, you see IDS IPS becomes a key part of that. And once you look at these and think about it, what was happening And as I described, exploiting the vulnerabilities, you understand why IDS IPS actually becomes a key feature to bolt on top of NSX with the firewall. Okay, so this is what the attack sequence looks like. The goal of this session, when you are finished running this lab, in your NDR dashboard, you should be able to see this screen. Now, I will show you how to sort of move things around, but after everything that we're going to do now, this is what we actually want you to see in your environment. So I'm going to flip to the dashboard. So if you guys want to follow, the lab guide, I think it's module 7, but I'll guide you through, actually just talk through it, it'll be a little bit faster for us. The first thing we want to do, actually let me see if I increase the, I want to see if I can zoom in and tell me if it's any better. I don't need the manual. Is that a little bit better for the guys sitting at the back? Awesome. So the first thing you want to do, go to inventory. On the left-hand side, there's groups. Click on groups. If you feel it's going a little bit too fast, just put up your hand and I'll slow down a little bit. Yeah, we want to add a group. So click on add group. And then just give the group a name. I just call it ATP demo. That's easy to remember. Click on set. At the top left, you see membership criteria or members. Click on members. So we actually, in this group, we're going to physically select those 3 VMs, which was VDI, front-end web, and database. So if you look on the left-hand side, or actually on the right here, there's a scroll down. You want, one up. Under category, there's groups. Do the drop-down menu and select virtual machines. That will expose the list of virtual machines that the NSX manager is aware of. This is pulled out of the vCenter when we install it. So if I scroll down here, the first one you see is backend database. You want to click on the left. So you should see the number 1 increase to number 2 as we go through this. The next one is front-end web. Select that one. And closer to the bottom, you're going to find the VDI desktop. VDI 001. You should see 3. If you scroll the little bar down on the right-hand side, select show only selected, and just confirm that those are the 3 VMs you see. If that is fine, click apply, and then click save. Cool. Everybody at this point? Looking good? Fantastic. Now what I want you to do is click on security in the top, so that sits between networking and inventory. You should see the security dashboard. If you click on IDS IPS, so that sits next to campaigns. You should see data center IDS IPS not prepared. Hold on just 1 second, the zoom is actually, there we go. Give me 1 second, I think when I zoomed in, I actually lost the bottom half of the screen. No. Okay, so just go to setup. You should see this screen. What we're going to do is we're going to skip the tutorial. We're going to just quickly manually configure this. So skip setup. And you should see this UI. Let me zoom in again. So what we want to do now, so Jason mentioned earlier, when we install NSX the first time, so when we do what we call the host prep, you actually already have the NSX modules already inside that ESXi server. So all we want to do now, first is we're going to go to settings, then select IDS IPS in the middle, top. And you see there, you should see something about it. There's a new update available. So the first thing we're going to do is we're going to enable the actual auto update of the IDS IPS signature database. Depending on your environment, This can be done through proxy access that you configured in the NSX manager, or if you have a dark site, you can do a manual upload of the actual IDS IPS signatures. So go ahead and enable auto update. If you take a look just below that, you'll see there's a signature count of 10,000. This should change in about a minute as it's updating. We can leave that to carry on in the background. Let's go ahead now and click on profiles. So that's just slightly up next to settings. You see IDS, IPS, and malware prevention. Let's keep it on IDS, IPS, and say add profile. This profile allows us to filter signatures that we want to apply to specific workloads. So that by default, the system has, it's still updating. Mine shows 3,000 signatures. It should, once the signature database updates, it should be about 11,700. But this gives me the capability or the flexibility to remove certain signatures that might not be specific to my workloads. So why apply Linux signatures to a Windows machine? Now what that does, it reduces the amount of false positives that you get out of the system. It's not there for performance, it's really there to improve the quality of the signatures that are triggered in the environment. So I'm just going to quickly refresh. Let's add a profile. I just want to make sure, go back. I just want to make sure that I actually have all the signatures updated before I add this profile. Yeah, okay. You should see 11,715 signatures. If not, exit from that and come back. And yeah, I'm just going to call the profile ATP profile. For the purpose of the demo, I'm going to leave it default. So I'm actually selecting all 11,000 signatures. Scroll down and click save. Cool. Pretty easy. The next thing we want to do is we actually want to enable IDS IPS and the malware solution on the cluster. So if you go to the top right, settings, in the middle you see shared IDS IPS malware prevention. Click on IDS IPS. Oh wait, where am I going? Shared, sorry, go back to shared. You'll see at the bottom, if you go to scroll down slightly, you have the option to activate this capability either on a host or you can do it on a cluster. Now, we really support it. If you have a vCenter cluster, you should enable it on the full cluster. You don't want to enable it on a host within the cluster. So scroll down a little bit where you see enable IDS IPS on the clusters. Select the region comp01 on the little click box and switch the toggle on for IDS IPS. So as we do this, we're basically starting the IDS IPS engine on those ESXi servers that are inside this compute cluster. If you see any alarms like this, you can just clear it. Now the next thing we want to do is we're going to enable this same capabilities plus the malware on the NSX gateway, so the north-south traffic. So scroll down a little bit, you see a T1 called T1 gateway and a tier 1 called VDI. You can just select them both and turn on this capability. So enable IDS IPS on both of them. And the same for malware prevention. So I mentioned earlier in the distributed model, we use the service VM that we would install on each ESXi server as the sandbox. In the north-south traffic, we actually use the NSX edge that is allocated to that T0/T1 for that capability. And at that point, we actually intercept the file on the uplink of the T1 to the T0. In a future release, we'll have this supported at a T0 level as well. Today, it's only supported on a T1. That's why you see me enabling this on the T1. Cool, so let's speed it up a little bit. The last piece that we want to do is some rules. The rules is what we are actually now going to do to start catching the traffic that we're going to simulate. So let's go ahead and configure distributed rules. Say add policy. So this look and feel just like the actual firewall policy, the DFW. If you want, you can give it a name, just call it IDS or IDPS. Click on the 3 dots on the left-hand side, add rule. Now, to save time, I'm just going to skip the names. But if you scroll to the right, you see security profiles. If you click on the little pencil, you see the ATP profile. So that was the IDS IPS profile that we created. If you want to expand it, you can see all of the signatures that are included. So apply. And now we want to change this apply to field instead of being the DFW. So if I leave it a DFW, I'm basically enabling IDS IPS on every single VM inside the cluster. So click on that and select groups and just look for that ATP demo. Here we go. And at this point, I'm just going to leave it in detect only. So this is a IDS rule that we're creating. Once you have that, just say publish. Everybody reached this point? Okay, then we'll help. Now let's go, and the last bit of configuration, and then we can actually start the fun stuff, is we're going to go to the gateway. So this is the T0, T1, and we're going to add a policy or a rule that enables IDS IPS as well as malware prevention on the traffic that is passing through that T1. So click all shared rules. So we're going to just create one policy and apply it to both T1, both T1s at the same time. So add policy. And you want to add two rules. So just double click on those three little dots and click add rule twice. So you see it looks very similar to those distributed rules that we had. On the very first one, go to the profile. And what you want to do on the top left is select malware prevention profile. So we want to have the malware policy above the IDS IPS policy. So if I click malware, I'm going to use the default malware policy. The difference in this malware prevention policy, it allows me to choose and selectively decide which files I want to inspect. So on the apply to field, select the top left little box. It chooses both those T1s and say apply. Edit the second policy or second rule. And we're going to choose the ATP profile under IDS IPS. And apply to will be both T1 or both T1s the same way we did for malware. If you've reached this point, you can publish. So basically, these two policies will now intercept the data that is passing through that T1 uplinks on the way either to another T1 or to a T0 and actually do IDS IPS as well as malware prevention. Anybody not reached this stage that needs a bit of quick help from one of the guides? All good? All right, so now if you click on the actual sidebar here, you see security overview. You start seeing some data here. So there's 0 active campaigns. This is the NDR correlation capabilities. If you click on IDS IPS, it's all blank. So what we're going to do now, if you open PuTTY and you scroll down and look for the VDI desktop, just double click on that. Let me zoom in here quickly. I just want to enhance it so that you guys can see it. The password is VMware OneBang, capital VM. I'm going to type it here in the UI as well so that you can see it. So just like that. So basically what we've done is we've SSH'd into that VDI desktop. Now I want you to do is CD, RC, tab, and you'll get to RC files. So we're changing the directory on that system to this RC files. If you do an ls on this Ubuntu machine, you'll see on the far left-hand side something called do bad stuff. So this is where you've come to Vegas and you now get to do bad stuff and not get into trouble. So the way we're going to execute this script, so actually the do bad stuff, it's a script that calls upon Metasploit. It will do a download of a malicious file. So it's basically simulating traffic flow through our environment. So go ahead and type ./D, and then just hit the tab. So it should run that script. And then go ahead and hit enter. So if I go back to my slides, let that run. It runs for about a minute or so. What we are doing now is we've kicked off the script on this guy, and we are now starting to actually run through some traffic and simulation of how the machine was exploited. It downloaded a malicious file, and eventually that malicious file gets executed, and we now have command and control activity on that machine. And from there, it now starts doing lateral movement to the web front. And once that is finished, so I'll go back to my screen. So this file runs for, I think it's about a minute, 2 at the most. What you can do is go back to your NSX manager and click on IDS IPS, or just refresh this page. Now you actually start seeing some of those IDS IPS events. So part of that attack sequence, we've started triggering the IDS IPS that we've enabled. If you click on the left-hand side here, you see IDS IPS as well. And yeah, we can actually now come and look at these IDS IP events. The easiest would be if you look at the top right, there's a little timeline button. Just close that, so it actually just closes that timeline of the events. And you can expand some of those events. Oops. By clicking on this little right arrow. And this event then gives you a bunch of details of what has actually been detected, on which machine it is happening, what is the signature in our signature database that has been triggered. You can go click on full event history. It actually shows you at the time it was detected. This was detected on the distributed IDS IPS engine, the workload affected, the IP addresses, and all these kind. So in my case, I was cheating a little bit. I just used new rule. In your environment, you would actually give some decent rules. So when you look at these logs, you can actually understand where the policy was actually triggered and stuff again. So if you go back to the PuTTY session, you should see VDI 01 complete. If you see that, just type exit. And in the meantime, let's open the front-end web. Again, same password, VMware, capital VM, 1 bang, or exclamation. Again, same process, CD, RC tab, so it goes RC files. If you want to do the ls again, you can. So this time we're going to say ./D tab. So you'll see it has a P1 there. So this is now a script that is purposely written for this machine. So just hit enter so that we execute that. So basically what this one is doing, we now have gained access to that machine. We've compromised the machine, and it's doing a similar flow again. It downloads the malicious file. The malicious file then enables the remote command and control on that machine, and then he runs through and then does some lateral movement again. What you will notice, the first one at the VDI, the exploit was actually using a magnitude EK. The actual lateral movement and stuff is using crypto wall. So that is the command and control, is actually the crypto wall vulnerability. So while this is running, let's go back to the NSX dashboard. Click on malware prevention on the left-hand side. Malware prevention is the sandbox capability.
I'm going to interject real fast, Quinn. If you don't have malware prevention on the left side, do a refresh
Oh, yeah.
of your NSX UI. Sometimes it doesn't pop up until that malware prevention tool is fully activated. So if it's missing, just do a refresh on the NSX UI and it will be there like you see on Quentin's screen.
For sure. Good point. You should see what I'm seeing. It's the file that was downloaded. Now you can either just, again, click on the graph in the top right so that it closes that visibility of the timeline. And you see this 100%. So this means the sandbox detected this file, so you can expand it. We detected this file. It was downloaded from, this is the VDI machine, 40.200. This is the external server that it downloaded from. Now once the second script completes execution, and we refresh the screen just now, this total inspections will change from 1 to 2. So if you click on that number 1, you can actually see this was detected on the gateway. So you remember the IDS IPS that we triggered earlier was happening on the distributed IDS IPS. So this malware file was detected on the gateway. It gives you the file name, the edge where it was, and then if it was blocked or not blocked. Now, today we only do detection on the gateway, so we wouldn't be able to actually block that file. Now, there's other details that you can have a look at here. So the hash file, MD5 hash, sometimes that is also useful if you're doing some external monitoring and want some more details. What you can also do is click on this button here, View Reports. This is actually a report that gets generated by the sandbox, and it does an analysis on the actual file. So depending on the file that it was, if it's an executable or a PDF, or any other file type, it actually goes and does a full analysis on that file. And in certain files, you actually will get a full report that shows you all of the executions that malicious file would have done had it executed in your environment. And you can see that here from the report. So if you click on the top there in the middle report, now this is a zip file. It's not usually the nicest report, but it does give you some details of what happens. So we can go ahead and close this. Let's go back to the SSH. Mine is still running. I'm not sure if anybody else is at this point. So this one should be finishing soon. I think it should be in about a minute or two. So let's do this in the meantime. If you go on the top right-hand corner of the screen, you have these 9 dots. So 3 by 3. Click on that, and you're going to see NSX NDR Network Detection Response. It opens a new page. So when we started the lab, we asked you guys, go and enable NDR and go enable malware detection. That part, when you enable the NDR piece, it actually goes and creates a tenant for you in our cloud environment. So we are taking the logs that were generated in the environment, running those scripts, and we are sharing those logs into the NDR dashboard, which is hosted in our cloud, and that is where all the correlation happens. So on the malware side, I said there was a profile. On that profile, you also have flexibility to decide if you want only static analysis done on-prem, or if the engine cannot determine if the file is malicious or benign. In the profile, you have an option that says send the file to this cloud environment. Now you'll start seeing here, we have a couple events or detection events. This is the actual correlation dashboard. If you click on the left-hand side here, events, and you start scrolling down, these are all the events that we generated over here. So this event correlation is happening in that engine. What it's doing at the moment is actually correlating VDI1 web front, and then when we do the database execution, at the end we're going to have this view that as a security admin or somebody in your system or from the NOC team needs to be able to check what are all the machines that were involved in what we refer to as a campaign, and where did it start, and what was the activities that was happening. So let me go back and see if my script finished. Okay, so if you're on front-end web back on the SSH, you should see complete by now. Go ahead and type exit. Open PuTTY again, and then just click on back-end database. So this is going to be the last one that we're going to execute the script on. Open that guy. Password is again capital VM, where one bang, or one exclamation. Same as before, cd rc files. Do an ls, or just type dot / capital D and tab and hit enter. So this executes the last bunch of scripts on that machine, which also now generates some lateral movement from the initial VDI machine to that host, as well as downloads a malicious file. File is executed. We have command and control back to that system. And at the end, we'll actually exfiltrate data from this database to a system outside. And we'll show you at the end how the campaign brings all of this correlation together and all of these events. Now, the importance of the firewall and the DFW, had you implemented that correctly, most likely you would not reach to this point. You do not want DNS traffic to be allowed to exit from the database. But what we are showing you here is not fictitious traffic. These PCAP files that we are using here is actually from real live attacks that happen on the internet or potentially in customers' environments. So these are PCAP files that we've taken. We've renumbered the IPs and stuff just so that it's not exposing any data. So this is real events that actually do happen. So let's see this one executes slightly longer. But if we go now and we stay on the actual NDR dashboard, I'm going to just hit the dashboard button at the top so it's refreshing my dashboard. If I scroll up now, you see I have more events. So as the events have taken place, more of these events are shared with the NDR dashboard. And you'll also see something here that says one active campaign. So the system has seen certain events that are correlated together across 2 hosts at the moment that says 2 suspicious file downloads and 2 network anomalies. And that is what has created this campaign. So if you click on that campaign, it starts now giving you more data to focus on. So it tells you what is the threats. At this point, it shows 1 host. It shows you to the MITRE ATT&CK framework, the attack stages that has taken place in this attack sequence. Now, it will take a good 10 minutes or so for all of these events that we've just created to actually correlate into the campaign that would look like this. But as we refresh it, by either going back to campaign, let's see, so at the moment it still shows 1 host, but the engine is actively working in the background. What we can do in the meantime is let's go to the events and confirm that we actually see all the events coming through. So if I look here, I see malicious file download from this server, command and control, and I only see 10 and 40. So this tells me the actual events from the database, which in our case is 30.200, are still not pulled through. So let's see if that is still running. Okay. There it's actually just downloaded the file. I'm going to refresh this a little bit. But you can scroll around a little bit on the dashboard in the meantime and just get familiar with, like I said, look at the events. If you want, let's take 1 event. What you'll notice on the top here, where did it go? You have a filter shortcut. You can either filter to all detected events, info events, or threat detection. Let's go down. Depends which one you have in your environment. Oh, if you get this extend time, just hit that. I think we're about 10 minutes from the end. Let's select one of these events. So if you click on this one, let's say Command and Control Empire Agent. So you just click on it once. You'll see on the right-hand side of the screen, it opens a dashboard. This dashboard gives you some details of that event. So it actually gives you a description of what is the threat, what's the threat class, this is command and control, the impact to the environment, so there's an impact score. It was a detection. And if you scroll down a little bit, it actually tells you the source and destination, and then you see it says signature. So that we know was an IDS IPS signature that was triggered, and that's the signature ID. You can actually click either on the event details, and again, you're going to get some deeper analysis of that event. So you can go look at either the evidence of that. In some cases, we actually create a PCAP file as well. So if, depending on your environment, it could potentially have a PCAP file for that, or it will show you the captured traffic. So this one actually shows the evidence. This was a URL that was accessed. And if I go back and look at the event, you'll see that it'll equal in that event details. So let me click on campaigns again. I just want to see how far we're at. Okay, so now what you see here is actually 2 campaigns. So it has taken what it saw initially as one campaign. So this was probably, it shows one host. Let's see if I open this one. Which host was this? So this is the VDI desktop, that was .40. Let me see the other guy.
It is also possible that your setup and your campaigns look slightly different from Quentin's, and that's very normal. Essentially, the timing of the running of the do bad stuff of the 3 different virtual machines, it might mean that you have one campaign with 3 impacted hosts. You might have something else looking a little different. So if it doesn't match Quentin's exactly, that's totally okay.
Yeah. So this is one of the lateral movement events that we see. So this was from the actual desktop to the web front, if I'm not mistaken, or web front to the desktop. And go back onto the dashboard. It normally takes a good 10 minutes for this to do all of the correlation. If I go back to dashboard and you've clicked down, you see the downloaded file list. So there you should have 3 there. This is basically coming back to our slide. This was because of each of those machines downloaded that malicious file each. So that matches to that. So we're basically taking all of the events that is generated through NSX or detections, sending it to the NDR dashboard, presenting it to you so that you can actually see it and read it and dive deeper into that. But the NDR piece is about correlating those events and giving you, as a network or a security administrator or a NOC operator, to go and focus on specific areas to see if there was a breach or something. This shouldn't take any longer. Okay, yeah, we can now start seeing this campaign is updated. You can see the status is open, it's still ongoing. But now I have 3 hosts here and 3 threads. So if I click on that, so the one thing I don't see here yet is the exfiltration event. So that is the DNS CAT protocol that I'm using to exfiltrate the data. So the engine must still be busy doing its job. Now what you can do is scroll down in the dashboard, and then you'll notice the icons that have the little black house on. These are your internal machines. So I tend to, oops, maybe I should use the mouse here. I use this little mouse and I arrange them, generally arrange them internal VMs on the left-hand side, external IPs on the right-hand side. And then just pull all the threads around like that. And again, yeah, you can click on the machine. If you look on the info button on the right-hand side, so I had it closed there. If you click on that, you can also then get all the either the events or incidents related to this machine. So you'll see there's 3 incidents that have been logged. And like that. Let me go back to the dashboard. It shouldn't take much longer. Three threads. I think in a few minutes' time we should have that completed. Is everybody else seeing at least 3 hosts in their campaign? Has everybody got a campaign? 2 hosts? Okay, cool.
We got a 3 back here. Nice.
Nice.
Very nice. So, Quentin, while we wait for the campaign to finish correlating, you want to pull the slide deck back up and we can just mention a bunch of the other labs and the survey and things like that. Make sure we get all the fun stuff built out. So we want to point out real fast, I know I'm not on the camera for this, but there are other components of this lab that we haven't covered today. Definitely recommend, right? We covered 2 modules out of 7 of a lot of really good content here. So definitely recommend if you have an interest in the NSX security suite, we got a whole bunch of cool stuff that we can throw up on here. So definitely try it out at some point. And we're not limited to NSX security. We have a whole bunch of labs that are NSX related and periphery. So NSX fundamentals, NSX advanced networking, NSX plus, right? This is the SaaS NSX effectively. We have a lab for vRealize Network Insight or ARIA operations for networks. We have a whole bunch of the edge services. We have a whole bunch of the advanced load balancer, the AVI load balancers. There's a whole bunch of NSX information here for you to learn. If you are an everything admin, you got to learn more than just NSX security. You got to learn everything NSX. We got you covered. Don't you worry. At the end, once you do end your lab, there is a survey. We value those very highly. So if you can take a couple minutes and just tell us what you liked, what you didn't like, where we can improve, that's incredibly valuable to us. So I'll only plug that once. I won't belabor it. But we appreciate you being here and taking the time. So we'll hand it back to Quentin for the last of the campaign.
Okay, so it's 3 hosts. At the moment, it's still on stage command and control. What we can do is actually let's check the events and see if that DNS cat event has pulled through. Oh yeah, so here at the top you can see it already. So the event itself, so the actual DNS cat data exfiltration activity is already logged into the system. It's just now actually going through the the correlation event to actually correlate that. So this one is now actually just zoomed in on that specific event. What I wanted to do is just make sure that the events that we have generated in the IDS IPS has actually pulled through here, and I can see that it has. So you can see all the events listed at the bottom. Let's see if it's actually finished running. Okay, so that one did finish. I'm going to exit from there. I think while we wait for that, is there any questions or any remarks? Maybe something you want us to clarify?
I'll remark that if you have anything showing up in your campaign dashboard, you get to go back to work and tell your boss you did bad stuff in Vegas.
Maybe if we go back to the NSX dashboard, we can maybe go scroll through some of the other stuff I can cover as well. So if I see I'm still on malware prevention. So if you are there, just maybe refresh on the top right. If you expand that, you see the client IPs and stuff. If you click on total inspections, you'll see the 3 different downloads, and you should see 3 different IPs. So it's the same file, just downloaded from 3 different clients. The other option that you might have, and depends if it's distributed, generally if you go to all files, you will actually see the distributed sandbox engine. It can scan all the files on your machine. So what I said earlier is on the distributed model, we actually intercept the file when it is downloaded and wants to do a data write to the disk. So if you have any other files on that machine, we could also inspect that. And again, it's on data write. It's not, if a file is dormant, you don't have an option to go and scan that file like an antivirus. It's really waiting for that file to either execute or copy and paste the file somewhere else or download it. And it's at that point where we actually intercept it and scan it. So if we go maybe click on the IDS IPS standpoint, dashboard, you see in the timeline here, we see all the different events that have popped up. Some of them different colors, some of them are suspicious events. Others are either depending on this impact score. But I'm just going to close the timeline again. Yeah, we see that DNS exfiltration event. Depending on the event, we do also provide CVE details or CVS details if it is related, if that signature is related to a CVE or not. So you can actually get that data here. Let's see if we have one of those. When we created the IDS IPS rule, I said we're going to leave everything in detect only mode. What you'll notice here on this little graph, you see this purple bar. The purple bar means it's a detect only event. So if I click on that or hover over it, it's detect only events. If we switch the IDS IPS engine and I put it into detect and prevent, and I run one of those scripts again, and you can do this at home, it's not in the manual, but you can take this afterwards and change it to detect and prevent, rerun the script, and you'll actually see some of these will actually be then prevented. And then obviously you won't see it in the campaign, but at least you get to understand the difference between detect and prevent. Let me refresh my campaign, see if it's ready. Oh yeah. So here now start seeing 20 events. Looks like it's taking a bit of time to come through. Ideally, when you have a bit more time at home, when this is running, you wait a little bit of time and you should end with that. Where was that? Oops. Let's go back. This is what the campaign would look like. So if you have a few minutes while we wait for this, feel free to scroll through the dashboard, or maybe if there's anything else you want me to show you. But yeah, I would encourage you to go click on incidents, click on the events, look at the details that you are actually getting out of the system. So maybe expand the filters. You could filter to specific events. Go to the detection events, select one. So we looked at hacking tool. Let's maybe look at the malicious file download events. If you double click it, it opens that page on the right hand side. Again, you get all the details specifically around that file. You can look at the details here. So it gives you which was the client that downloaded, what was the server it was downloaded from. So this one was from North Korea. Event IDs, incident IDs, all these data.
Perfect. We are technically over on our time here, and I want to be respectful. So if anyone does need to disappear for another session or a beer, totally understand that.
For sure.
So, however, Quentin and I, Lynn, we are happy to hang out for a while, answer questions. So if you have any questions, if you want to understand more about this, or if you want to hang out at your computer and wait for that campaign to finish correlating, feel free. But don't want to keep you from all the fun that is Explore. So thank you all for joining us. We really appreciate you. Have a great time.
Awesome.